Welcome. My name is Josh Almeida, and I am very excited to bring to you our latest installment of Focus on Learning, brought to you by New Bedford Public Schools and New Bedford Cable Network. While the best way to find out what your child could be doing at home is to work directly with your child's teacher in school, we know these videos will help everyone keep learning active at home.
Hello, Mrs. Guy back at you, and hello to my Ashley kids. Today, we're going to work on identifying polygons by their qualities. And now, a quality in a human is like, kind, supportive. But qualities in polygons, very different, much more specific. I'm going to pull this down, and we're going to start with triangles. Every triangle has 3 sides, 3 angles. The sum of every triangle, you have to add the interior angles. Those are the inside angles of the shape. When you add those up, it has to equal 180 degrees. So that the degree of angle A, the measure of angle B, plus the measure of angle C have to equal 180 degrees. Now, there's a reason I tell you this is because some of those tricky teachers you got out there, they're going to ask you, they're going to maybe give you 2 angles and then say, what is the angle of the third? What's the measure of the third angle? So you have to know that these 3 sums add up to 180 degrees. Now, additionally, we have 6 different types of triangles we're going to talk about today. One is a scalene, a right triangle, an equilateral, an acute triangle, isosceles triangle, and an obtuse triangle. All right, and then once we're done with triangles, we'll move on to quadrilaterals. So I'm going to grab my seat, and we're going to talk specifically about triangles. All right, in my journal and on the Elmo, I have, and this is my math journal from class, so this isn't anything unusual to anybody. We have the whole triangles, and we're going to start with the acute triangle. Alrighty, so let's look at the Elmo. We've got any triangle. An acute triangle is any triangle that every angle is less than 90 degrees. And EG stands for example given. These are 2 different triangles. Each of them is an acute triangle because no angle is greater than 90 degrees. That's an acute triangle. Now let's move up to the right triangle. And I like this one because it tells me, when you sit upright in your chair and, your mom and dad or meme, Pepe, Vavu, whoever tells you, come on, sit up straight, sit upright. And that's because they want you sitting at a right angle. And actually, that really is where it comes from. When you sit upright, your body and your legs make the right angle, a 90-degree angle. Now, a right angle is an angle that measures exactly 90 degrees. And I have 3 examples of angles right here on the Elmo. All right, we have one that's a standard one. You probably see that one, very familiar with that one. But then it could be reversed, it could be in a different shape. But again, each of these has one right angle. And then it does not matter what the other angles measure. As long as there's a right angle in your triangle, it is a right triangle. Alrighty, now another is the obtuse triangle. Alrighty, an obtuse triangle is any triangle with one angle that measures more than 90 degrees. And here are the examples I've given you in drawing. The angle here is absolutely greater than 90 degrees. And the angle here is greater than 90 degrees. The other 2 angle measures do not matter. All that matters is that you have one angle that is greater than 90 degrees. And those are the triangles by angle. Now we have some triangles that are described by their sides. Alrighty. The easiest one, the one probably most familiar to all of you, no matter what grade, K through 12, the one that's probably most familiar is the first one we're going to talk about, and that is the equilateral triangle. An equilateral triangle is a triangle that has 3 congruent sides. Now, congruent means exactly the same, almost like twins, that you can't tell them apart. 3 congruent or equal sides. And here is a perfect example of that. And it's hard to draw, actually, an equilateral triangle if you don't have a shape in front of you. This is exactly 1.25 inches, this side 1.25 inches, and this side 1.25 inches. Now I want to point out to you some geometric markings. When you see matching marks on a geometry shape, that is telling you that that is congruent. Whatever the marks on the shape make, if they match, they are congruent. They're exactly alike. So that's an equilateral triangle where you have 3 congruent or equal sides. Then we have the isosceles triangle. And when I think of an isosceles triangle, and I don't know why I have this in my head, but when I think of an isosceles triangle, I think of a popsicle. And I think it's because of the ending. You know, it reminds me of isosceles popsicle. I don't know why, but here's the thing. If you can remember, you know those twin pops? We have 2 little towers and the little 2 wooden sticks sticking out the bottom. You can break it in half and share it with your friends. Well, that's because when you break it apart, you'd have 2 equal parts. Just like an isosceles triangle, where you'd have 2 congruent sides. Any 2, it does not matter, as long as 2. And again, notice the marking is the exact same. So in geometry terms, the writer, the creator of this triangle is telling you that this line is congruent to this one, which means they're exactly alike. They're the same exact length. Alrighty? And then the third side does not matter. It doesn't have any rule to it. You only need to make an isosceles triangle to have 2 congruent sides. Here's one example, and here is another. And don't let those folks that are giving you quizzes or tests out there in the real world, in your classroom, don't let teachers, just because they've rotated it, don't let them trick you like that. You're smarter than that. Don't let those grown-ups get you, alrighty? That's why we deliberately put different ways in the math journal in my classroom. Alrighty, now the next triangle, measured by the sides, is the scalene triangle. Now this scalene triangle is kind of like well, if it doesn't fit anywhere else, it must be a scalene triangle. And that actually is true. A scalene triangle is a triangle that has no congruent sides. Alrighty, so this side is a little bit longer than that, and much longer than that. Here's another example here. You have a very short side, and a leaning side, and then the longest side, the hypotenuse. And then another example where you have wider and wider, but no length is the same. All right, so now those are scalene triangle. That's a scalene triangle. So now what I wanted to talk to you about was going back to our calculation. If we have a request, if we're given a triangle that, say, for example, is, we're given a triangle that says this, and your teacher gives you this measure of 20 degrees and this measure of 60 degrees, and your teacher says to you, what's the measure, what is the value of the third angle? You're going to remember that angle A plus B, zoom in a little bit, plus C, and now those letters just represent the different angles on your triangle, equals 180 degrees. So I already know 2 of them, so I could say 20 plus, and I'll put B for 60, 60 plus C, that unknown angle, equals 180 degrees. And I'm pretty sure that this is just a review, but I just want to make sure Because if it isn't, I want to make sure you have time to swallow this and then digest this. Put it in your brain and keep it there. Alrighty? So now I can do 20 plus 60. Well, I know that that's 80. Plus some number gets me 180 degrees. Well, gosh, easy peasy lemon squeezy, right? 180 degrees minus 80 degrees is 0, 0, 1. So angle C equals 100 degrees. And that's how you would calculate it. It's easy, really, truly easy peasy. Again, this is that part whole that you are used to dealing with in class. You're giving some pieces, but a missing piece, but you have the total. And again, a part whole equation. All right? Now, I want to go to quadrilaterals. And let's remember that every quadrilateral has 4 sides, 4 angles, and here's a change, the sum of the interior angles. Again, interior is the inside angles. The sum of the interior angles is 360 degrees. So that when I add angle A, angle B, angle C, and angle D, I'm going to get 360 degrees. So now, let's find that page that we made in class about quadrilaterals. Alrighty. First one is my favorite. And the reason I say that is because when I was teaching this shape to kindergartners years ago, one of the little boys said, "Mrs. Guy, is that where they trap the Zoids on the Zoid cartoon?" And of course, I didn't know what the Zoid cartoon was, but I said, "Yes, that's exactly it, Zachary. That's it. The Zoid cartoon. This is where they trap them." And then, of course, he justified it. So take a look at the trapezoid. Little Zachary's justifying how they trapped the Zoids was because they would crawl up the angles and then they'd come down. And once they're in, they can't crawl back up those because it's the wrong direction of the angle. Gravity's not going to allow them to just sit there and rest. And so I thought it was a great thing to remember. So to trapezoid, you need a trapezoid. So now, to get back to the geometry part of it, a trapezoid is a 4-sided shape. One pair of opposite sides is parallel, and that's the only rule. Here, in this standard, or isosceles trapezoid, and this is the one most kids have learned, but I want you to know that there are others. This one is the standard one. The top and bottom lines are parallel to each other. And again, I know you remember, but I'm going to say it out loud. Parallel means that they are running side by side and will never, ever touch, no matter how long the lines go. I remind myself and my kids that the word parallel has 2 L's side by side that never touch, just like 2 sides on this trapezoid. They'll be side by side, will never touch. And L, the double L, is like train tracks, and that's how I remember parallel. Here, though, is another trapezoid. This trapezoid is still a trapezoid, but it's just not one that people are used to seeing. As well, this one. And again, it's part of the reason that I do these different examples in class, because I don't want the kids thinking, oh, that's the only trapezoid, so I only have to memorize that shape. It's not the shape that you need to memorize, it's the rule. 2 parallel lines, no other angles matching, the other sides do not have similar patterns, nothing. 2 parallel lines, and it's a 4-sided shape, that could be just a trapezoid. All right, so now moving up to the parallelogram, we have a little bit more now being asked of to make a parallelogram. A parallelogram has the opposite sides are equal and parallel, just like the trapezoid. Opposite sides equal and parallel. Both sets, though, of opposite sides are equal and parallel. And the opposite angles are both equal and parallel. I'm sorry, the opposite angles are both equal. So opposite angles are going to be congruent, and opposite sides each will be congruent. That's what makes a parallelogram. These are other examples of a parallelogram, and yep, I know you're thinking, Mrs. Guy, that's a rectangle. But my loves, rectangles are parallelograms. Every rectangle will be a parallelogram, but not every parallelogram will be a rectangle. And here's why, because we're going to talk about rectangles. The only change in a rectangle requirement is the 90-degree angles. Parallelograms do not require that. You can see that here. These are not 90-degree angles, but every rectangle must have 90-degree angles. The opposite sides are congruent and parallel. The opposite angles are congruent because they're all 90 degrees. And this is what a rectangle might look like. Don't get caught up by thinking they all sit on their base. Some of them can be angled just to make you think harder. That's a rectangle. So as you can see, a rectangle does follow parallelogram rules. Opposite sides are equal and parallel. Opposite sides are equal and parallel. And the opposite angles are also equal. Well, they're all 90 degrees, so they have to be equal. And so that's why I can say to you that a rectangle can be a parallelogram. Every rectangle will be a parallelogram, but not every parallelogram is a rectangle. And that's actually kind of important to remember. Alrighty, moving on to, I've got two more in my quadrilaterals. We have the rhombus. And the rhombus, a lot of kids in the olden days, a lot of kids learned that this was a diamond. And only in jewelry is this a diamond. In mathematics, it's a rhombus. And here's what the rules are for a rhombus. Opposite sides are parallel. All sides are congruent. And the opposite angles are congruent. And I want to zoom in a little bit more on this big one where we have the angles measured out, marked out for you. Opposite sides are parallel. I'm sorry. Opposite sides are parallel. Opposite sides are parallel. All sides are congruent, so that's why they all have the same geometry mark. They are all congruent to each other. And then opposite angles are congruent also. Opposite angles congruent. And now we'll zoom out, we'll show you the others. And you're looking, I know you're saying it. I can see you saying it in your head. Mrs. Guy, that's a square. Mrs. Guy, that's a square. Yes, my darlings, it is a square because every square is a rhombus. Every square is a rhombus. Not every rhombus is a square. All right, rhombus has less rules than the square, but the square has every rule that the rhombus has. It has a little bit more. And we're going to take a look at that right now. The square has opposite sides are parallel. They go in the same direction, never touching. All sides are congruent, just like the rhombus. But all angles are right angles. So every one of these corners measures 90 degrees. Every square will have 90-degree angles. And no matter what the size, as long as the length and the width are the same measure, and we have 90-degree angles, that's a square. And again, here it looks like a rhombus, but it's still a square because all sides are parallel, opposite sides are parallel, and all angles are 90 degrees. So, just as a remember, every square can be a rhombus, but not every rhombus can be a square. Well, that was really fast, but that is what we're looking at today. Triangles and quadrilaterals and how you can decide which they are by their properties or their qualities. All right, this is Mrs. Guy saying, be good, be safe, be happy. Bye-bye.